गुड इवनिंग एवरीवन. हाय एवरीवन, होप यू आर डूइंग वेल. आप सभी का अगेन मोस्ट वेलकम एंड स्वागत. वी आर गोइंग टू स्टार्ट टुडेज सेशन ऑन मैथमेटिक्स at the platform of Resultant. So we will discuss about first some topics of number system, because we are going to start with the topic that is number system. This is details about me, you can see here. Come to the point, and students who will see the session after recorded form, then I will request you, please have a patience. We will discuss each and every concept in very depth, but we have to take time. Okay, so let's start. The topics which comes in the topic, that is number system, and we can say subtopic of the number systems. First, we will discuss about introduction of numbers. That is topic of today's introduction of number system. Another second topic, that is unit digit concept. Unit digit concept, because that component have important for your RRB JE maths components in CBT1, because many questions asked from number system also having these topic which is I mentioned here. Third is a reminder theorem. Together with that, we will also study about binomial theorem, which is related to only the concept of reminder. We will relate both theorems. Next, divisibility concept. Next, LCM and HCF. Next, we will discuss about factors. Next, we will discuss about number of zeros. Next, we will discuss about surds and indices. Next, we will discuss about square and square root. Last topic, that will be cube and cube roots. So these are the topics we have studied in this component, and you know very well RRB JE segment first or CBT1. This is the component of maths, and we will start from the topic first, that is introduction of numbers. So we know very well there are some basic things in the number system. We will try to understand what are the kinds of numbers, what are the difference between these kinds of numbers. So hopefully there is no problem here. Please, yes, if yes, so please inform. I will take your comments. Nobody is here live. Someone, if yes, then please comment. It's okay. Write down the points. Come to the next. When we studied about number system, we categorized it in two parts. First is decimal number system. Decimal number system. In the part of competitive segment, we can say non-technical, There are two types of number system are important only. That is, first one is decimal number system, another is binary number system. Binary number system. So we will study only two components. First one is decimal number system. Second one is binary number system. Why binary number system is going to important in non-technical segments of math? Because many other commissions have asked the question from this number system. So we should study also that, because nobody knows which component will ask by the commission, like RRB and other commissions. So first of all, we will start from binary number system. We will discuss in each and every point in shorts, but we will study decimal number system in depth. So first, you can take heading binary number system. Binary number system. So you know all very well, by means 2. So this number system can be written by using only 2 digits, that is 0 and 1. In the binary number system, we can write each and every number by the using only 2 digits. First one is 0, another is 1. How? Let's see. I'll tell you a very short method. I'm not explaining in depth, but I'm trying to say you that we will discuss only important fact of this number system, because it's the part of also a computer, but we will not study about the components of computer. We will only parts of math. So write down here, we write here 1, we double, we get 2, and after double we get 4, again double we get 8, again double 16, and now again double 32, and we will, as per requirement, I told you, write 1 by using 0 and 1. So you will say, here is already mentioned 1, so you take over 1. But I told you write 2 in binary number system. तो 1 आपने 1 लिख लिया, you wrote 1. But अगर अपन 2 लिखना चाहते हैं, how will write? Please look at here. Once we have to go nearby 2, we will meet first one, but we have no need to write 2 of 1. Means if we have not required of any digit, we will write 0 for that. If we will require to the digit, and we will write 1. So I have to need write 2. So I will not use 1. Then I will use 0 for which digit I am not taking. And I am taking 1. I am taking 2. If any digit I am taking, then I will use for that 1. There are two concepts here. When we use any digit, then I will write for 1. When don't use any digit, we will write 0 for that. अपने को अगर किसी डिजिट को यूज करना है, अपन उसके लिए 0 लिखेंगे. अगर यूज नहीं करना, सपोज, वी विल राइट 1 फॉर दैट. इट्स ओके. नाउ I write 0 and 1. It is 1 0, but it is 2 in the binary number system. Now I want to write. Now I want to write what? Suppose 3. I want to know how we can create 3 by using this numbers. How we can write 3 by using these numbers. So you will see, here is not, we are seeing here directly 3, but we can create 3 by adding 2 numbers, right? So first number is 1, another is 2. So we can add 2 plus 1, we will get 3. So we have required 1 and 2 both numbers. Then I will write 1 because we required 1. I will write 1 because we required 2. I told you if we use any digit, we will write 1. If we don't use the any digit, then we will write 0. So I required 1, also 2. So after adding, we will create 3. So number will be written 1 and 1. So 3 will be written 1 1 in the form of binary number, and we will say that is 3 in decimal number. Next. So I can understand, hope you will guys understood this point, and I would like to say one thing. If you can understand two things only, first one is if you use 1 when you use any digit, you will use 0 when you don't use any digit. Simple two things are here. Again, we have to write some digits, then you can, like I want 10. How we will write 10 in decimal number system? So you will guess what is the number less than, just less than 10 in the series. So you will see 10 is less than 16. 16 से छोटे जितने भी numbers हैं, these are small from 10. 8 is just a small number before 10 in the series. So we will use 8, and what number should we add in 8? We will get 10. So 2 is single number. When we will add with 8, we will get 10. So we required only 2 digits. First one 8 and another one is 2. But 1 and 4 we don't use. I told you last, when we don't use any digit, we will write 0 for that. I don't use 1, we will write 0 here. I don't use 4, I will write 0 here. But I use 2, I will write 1. I used 8, I will write 1. So 10 will be written in the form of binary number. We will write 1010. That is basic concept. Now, another last number we will write here. Then we will come to the next component. Again, come back, create the series again. 1 2 4 double करेंगे 8, again double 16, again double 32. I'll ask you how we will write 20 in binary number. So you know very well the number which is mentioned here is just less than 20, that is 16. Just less than number 60 in the series from 20. Then we will think what number should be added in 16 will create 20. So you know very well 4 is the number, when we'll add in the 16 we will get 20. So we required only 16 and 4 to create 20 by adding these series. Then 1, 2 and 8 we don't use. Then we will write 0 here, we will write 0 here, we will write 0 here. So number becomes in binary number, that will be 10100. That is binary number of 20. So hope there is no problem here. So come to the next, and now we will understand reverse, that here written in the binary number, that is 10100. Find the decimal number, find decimal number, because decimal number when that number given in the binary number. Okay. Next. So now see, we will write just double series here. Start from the unit digit. We will write 1 here. We will just double. We will write 2. We will just double 4. We will just double 8. We will just double 16. Which digit have just upon 0? We will cancel that because we cannot take over digit of 0. We will not use 0. Then we will cancel that. We will cancel that. We will cancel that. We have only two numbers, that is 16 and 4. 16 plus 4 will be 20. That is the cross check. जो अपन ने 20 लिखा है here, that same number can create in against reverse in decimal number, and this form is 10100. That is in binary number. So we have studied binary number as per required of the component, and now come to the decimal number. Hope there is no problem here. If everything is fine here, please confirm. Come to the next. Again, now we will discuss about decimal number system. In decimal number system, we studied about real numbers, because imaginary is the part of technical maths and real numbers is the part of non-technical maths. So we will see here real numbers is divided in two parts. First is decimal number, and second part is that integer. Second part is that integer. Okay. Next. Now see, again decimal numbers are divided in two parts. First is terminating decimal. First is terminating decimal number, and last is non-terminating decimal number. Why and who is regularly messaging me? I'm busy right now in class. Close. Now, sorry, I told you decimal number system divided in two parts. First one is decimal, terminating decimal, and another is non-terminating decimal. Now we will study about decimal. कौन सा वाला भाई? तो terminating. So first, let's see the example. I wrote 2.45. So you can see here, after decimal, we can count the digits. When after decimal digits are countable, we can see that is terminating decimal. Terminating decimal. How you can define non-terminating? So let's see. When I wrote here 1/3, and you will calculate it, and you will write in decimal number 0.3 3, 3, 3, 3, 3. It will never be end. That will be written infinite times. Then we can say the digits after decimal are not countable. It's okay. So now we can say here, after decimal, if digits are not countable, that category of numbers is defined non-terminating decimal. Category of number will be defined as non-terminating decimal. If everything is fine here, then please confirm. We will next, please. Come to the next. There is no problem here. Now see. Again, I can write here. Again, we divide non-terminating decimal in two parts. Non-terminating decimal, non-terminating decimal divided in two parts again. First category is that when after decimal digits are in a proper pattern or repeating pattern. Listen again. When digits and any pair after decimal are repeating, like for example 3.2525 up to the infinite. First category. Example again 3.178942736 up to the infinite. Now we can say here there are two categories of non-terminating decimal. This is non-terminating because ending with infinites, because we don't know how many digits after decimal. Then we will see here 25, 25, 25, 25, 25 up to the infinite is the series. Then we will see 25 is the pair and repeating same up to the end, and there is no countable end here. Now that kind of non-terminating number is called repeating non-terminating number. कौन सा भाई? Repeating non-terminating number. Non-terminating number. In next example, you can see after decimal digits are not countable. Therefore, we can see non-terminating, but also not repeating. There is no fixed pattern. In second example, we can see 3.1789422 means this kind of non-terminating number will be called non-repeating, non-terminating, non-repeating and non-terminating. Now see one important thing. When the category of non-terminating and non-repeating means non-terminating मतलब term end नहीं होते, and non-repeating means there is no fixed pattern of repeating. This kind of number is called irrational number. This kind of number is called irrational number. Irrational number, and we can't write that form in P and Q. We never can write these numbers in the form of P upon Q. So non-terminating, non-repeating type number cannot be written in the form of P upon Q. ये लिखा ही नहीं जा सकता. Not possible. Correct? And proper example is that pi. ठीक है। तो पाई इज irrational number because once you got the exact value of pi will be 3.14 and some such series in not the perfect repeating. If repeating is not perfect, then number will be irrational number. And you know very well pi is equal to 20 upon 22 upon 7, but it is not correct. Now we should at least understand one thing clearly. 22 upon 7 is not exactly pi. Never. It is nearest to the pi because 22 upon 7 is the rational number because it is written in the form p upon q. That is rational number because it is written in the form p upon q. But pi, the value of pi will be 3.14 and such series which is not repeatable. अगर आप कैलकुलेटर से भी सॉल्व करेंगे, it will be not find out because having a exact digits, है ना? So you can go for Google and cross check the digits. So the series of is not repeatedly a non-repeating number. If that is non-repeating number, therefore pi is called irrational number. Pi is called irrational number. So should be a clear mindset about the category of numbers. If you are too comfortable with the understanding of numbers, I am sure I will guiding you at such top level, then you will definitely solve the question which will comes in the examination. So I am requesting you, please focus on the concept and make some proper notes of this topic. And in 3 days in week, I will definitely guide you for such components of CBT1. Now, come to the next. I'll clear this component from board because there is no proper blank space. ठीक है? So now, we have studied what decimal number divided in two parts. We studied what type, first terminating number, terminating, and second was non-terminating. And we again categorize non-terminating in two parts. First is repeating and second is non-repeating. But I told you we cannot write non-repeating and non-terminating because this is the part of non-terminating number. Cannot be written p upon q form. Therefore, it is called irrational number. Then we want some example. So you can write such numbers which have not a exactly perfect square number, like if I go for root 3, if I will go for root 5, if I will go for root 7, if I will go for root 10, means this is are the number having not a completely perfect square number, and I use for the square root of these number the values gives from these category numbers we will get in the form of non-repeating, non-terminating decimal. Then we will solve these roots. We will not get a perfect square number. We will not a integer. We will get such numbers which will be written in the form of non-repeating, non-terminating decimal. Therefore, we can say the number which is not perfect square and we use for the root for that, that number will be irrational number, and we cannot write this in the form of p upon q. But now we can write two numbers in the form of p upon q. First is repeating and second is terminating. Both category of number can be written in the form of p upon q. So now we will study how we can write these numbers in the form of P upon Q. So first question can be asked from here, and also for the add, examiner can ask from you how to add these category of numbers. So now come to the point, and we will try to write in the form of P upon Q. First, I will discuss about terminating decimal number. Terminating decimal number. It is very simple and everybody knows about that. How? I wrote here 4.576. Write this number in the form of P upon Q. You have no worried. Why? Because we know very well the number will be written same without using decimal here on the place of numerator, and in the denominator we will write what? We will use 1 at the place of decimal, and we will count how many digits after written decimal. So we will count 5, 7, 6, and total 3 digits are written here. So this is the form of P upon Q, and we can also write this in short form dividing by the number which is cancelable. Please tell if there is no problem here. Come to the next. If everything is correct here and everybody is understood, so please confirm once, then we can go ahead. Now, next, we will take over another example in the same pattern. Suppose we write down here 9.78, write in the form of P upon Q. How you will write? You know very well that numbers written be same on the place of numerator without using decimal. So we will write 978. Now we will consider decimal as a 1. We will write 1 in denominator. And how many digits after decimal written here? 1 and 7 and 8, any 2 digits. So we will write 2 zeros here. And we can also calculate it in short form, but we want to write in P upon Q. That is, the form is perfectly written in P upon Q. So there is no problem here. Now come to the next point. Again, come to the next. That is नॉन टर्मिनेटिंग नंबर, और उसमें भी कौन सा कैटेगरी? रिपीटिंग. यू कैन डायरेक्टली राइट हियर रिपीटिंग नॉन टर्मिनेटिंग नंबर. नॉन टर्मिनेटिंग नंबर. Let's see. I wrote here 0.353535 up to the infinite. Question is that write this number in the form of P upon Q. Please write once. Please write once. Anyone try? Let's see. You know very well this same number can be written in the short form by using bar. So now we can say this number also can be written in the form of 35 is the one pair which is repeating multiple times or unlimited times. So we will use a line that is called bar. That is called bar. So now same number can be written in the form of 0.35 to the power, to the 4. So now we will write it in P upon Q. So we have to see 3 5 written on the top, but how many digits have bar? So there are two digits 3 and 5 having bar. So we will write 9. We will write 9 for 5. We will write 9 for 3, and double 9 will be written in denominator. The number becomes in the P upon Q by writing 35 upon 99. Correct? Chalo. So hopefully there is no problem here. I will write again example. Write again 0.786 up to the infinite. Up to the infinite. Now see, this number can be written also another form, 0.786 to the power, to the bar, that is written in the form of bar. Now we have to see one thing. How many digits are written here? 786. We have write same. But how many digits have bar? All three digits have bar. So we will write 9 for each digit. If there are three digits here, we will write 9 here, we will write 9 here, we will write 9 here. The same component will go on to the denominator section. It will be written 786 upon 999. So that is the form of P upon Q. This is the first category of this number. I think there is no problem here. If yes, then please confirm. Now come to the next, another example. I told you 0.45656565656 up to the infinite. Up to infinite. Now see, we can write 0.4, but 4 is not repeating. But 56565656, the pair of 56 is regularly repeating. So we can write here 56 only one time, and we will take over bar only digits, the pair of repeating. There are only pair 1, that is 56 is repeating, 4 is not repeating. 4 is written only one time here. So now we will written that 456, and if 4 have also bar, then we will nothing change and we will come under the denominator. But here also having 4 and 4 have not a bar, then we will minus 4 here, because if any such digit before the bar having no bar, we will minus that. And now we will write 9 digits which have bar, we will write 9 4 digits which have bar, we will write 0 which have no bar. Then which have no bar, if we will write 0 here, there is no value, then 0 comes to the right. So now we will write here 990. Try to understand it again. I wrote 9 if 6 has bar, I wrote 9 if 5 has bar. If 4 has no bar, I will write 0. But if we wrote 0 here, there is no value of 0. then we will transfer 0 from right side. It will be written 990. So now we can solve 456 minus 4 means 4, 5. Here will be 2 and now 990. That is the form of P upon Q. If everything is fine here, please confirm. It's okay. Now come to the next. Let's see. I write again example and same pattern 0.2, 34, 34, 34, 34 up to the infinite. Up to the infinite. So now you have to write in P upon Q form. So you will write here 0.234. But 234 is regularly repeating. So we will write bar on 34. We will take over bar on 34. So now we draw the bar here. We have to write in the form of P upon Q. So what we will do? For P upon Q, we will write single times 234. But if any such digit which have no bar, then we will minus same digit. So we will minus 2 from here, because I told you many times, if such a digit as before which have no bar, we will minus. So 2 has no bar, we will minus 2 upon, we will write 9 4 digit which have bar, we will write 9 digit which have bar. If there is no bar on 2, we will write 0 for this, but if we write 0 here, there is no value of 0, then we will write 0 from unit place. Okay? We will write on unit place 0, and now it will becomes 990. Then you will minus, we will get 233 upon 990. That is also in the form of P upon Q. So this is the basic introduction of converting decimals numbers in the P upon Q. Now come to the point which is bar. Okay? So we have seen all the concept. Okay? Now come to the point on integer. So we have studied one part of decimal numbers. Yeah, we can say decimal number system, that is real numbers. So real numbers divided into two parts, decimal number and another part is integer. So now we will oral discussion of integer for few minutes. So integers are divided in two components generally. 0 is integer but not having a nature positive and also not negative. So 0 is neutral number, but we will go for write down in number line. We will draw +1, +2, +3, +4 up to the plus infinite. This category of integers is called positive integer. This is called positive integer. If we will go left to the 0, then we will write what? Then we will write -1, -2, -3, -4 up to the minus infinite. This category of integers is called negative integers. And now We also categorize with few names as the positive integers is called natural numbers. Always remember, the positive integers is called natural numbers, and also same natural numbers is called counting numbers. Natural numbers also called counting numbers. Amit Kumar ji, you comment, but कमेंट में आपने कुछ लिखा नहीं है. नो प्रॉब्लम. Come to the next. Okay. When we include zero with positive integers, the name becomes whole number. The name becomes whole number. So see here, natural numbers starts with 1. Natural numbers starts with 1, 2, 3, 4, 5 up to infinite. But whole number starts with 0 because I told you natural numbers में अगर आप पहले 0 लगा देंगे, if you will add 0 before natural numbers, then it will becomes whole number. So whole numbers starts with 0, 0, 1, 2, 3, 4, 5 up to infinite. Okay. So this is the basic introduction of a number system, and such categories of natural numbers are here. So I will categorize natural numbers again. Natural numbers categorize in 2 parts again. Natural numbers categorize in few parts, like first type of natural numbers is prime number. Second category is composite number. Third is co-prime number. Now see what is the prime numbers. So only one perfect definition of prime numbers is that having only 2 factors. Having only 2 factors. For example, 2 have only 2 divisors or 2 factors, 1 and 2. 3 can be divided only 1 and 3 divided by 1 on 3. But 4 has not only 2 factors, because 4 can be divided by 4, 4 can be divided by 1 and 4, but 4 also can be divided by 2. But prime number told having only 2 factors, that factors will be, one factor always will be 1 and another factor always will be itself, that is number. So there are 2 factors of each number, that kind of number will be called natural number. But if such numbers having more than 2 factors like 4 is called composite number. So first composite number is 4. Again 5 will be prime number and 6 will be composite, because 6 can be divided 1 and 6, and also it can be divided by 2 and 3. So in that case 6 have a total 4 factors, but prime number told having only 2 factors. First is 1 and another is itself. So now 4, 6 and 7 will in the category of prime number, and 8 will go in the composite number, 9 also in composite number, 10 also in composite number, 11 come to the prime number, and such numbers are prime. Now come to the point, co-prime number. So you know very well, first prime number is 2. Okay? And this is alone even number. So 2 is called even prime number. Okay? First composite odd number. First composite odd number is 9, because all other numbers are even, but 9 is first composite odd number. Now come to the next co-prime numbers. So co-prime number is the pair of two numbers. Co-prime number is the pair of two numbers. Pair of two or more numbers. मीनिंग क्या निकला भाई इसका? Such two numbers having HCF 1. Such two numbers having HCF 1. It simply means two such numbers, suppose 3 and 5, cannot divide maximum more than any number which is more than 1. This is the category is called co-prime number, like 5 and 10. It will not be co-prime because it can be divided by 5 also, it can be divided by 5 also. But co-prime number said both number cannot be divided any large number any more than number which is more than 1. So this is the category of co-prime number. Such values of co-prime are defined as, we can say, two composite numbers always be co-prime. Two composite number always be co-prime. Always be co-prime. It simple means any two number which is consecutive. Sorry, two composite means two consecutive. I'm sorry for that. There is word not composite, that is consecutive. I'm really sorry for that. By mistake. That is consecutive number. Two consecutive like 3 and 4, 5 and 6, 9 and 10, 99 and 100. All such pair of two consecutive numbers always be co-prime. So this is the introduction of number system. And next class we will also on Friday. Then we will meet on 5 p.m. every day on YouTube. And we will 7:30 meet on application of Resultant. Thank you very much for joining us. Thank you. So,